All right, today obviously we're going to talk about distance and midpoint right here. Let's start talking about distance first. Here's a little example I usually give. Let's say you're going down a road, you're on a road trip or something, and you ever see those mile markers on the road tell you how far you've gone, how far you're supposed to go. So let's say you're going down the road, and here's an exit. Excuse my writing. That's the Golden Arches. That's McDonald's. Okay, that's usually my favorite place to stop. So let's say you're traveling down the road, and here you are in this cool looking car. All right, you can stop laughing now at my car, but that's my car. It kind of looks like a spaceship or a minivan or something. I don't know. But anyway, I'm going down the road, and let's say we are at the 5 mile marker. Okay, so these are mile markers. It doesn't mean I've traveled 5 miles. It means this is the mile marker that I am right now. It's at the 5 mile marker. Okay, and you know that your McDonald's is at the, I don't know, let's make up something. Let's say the 17 mile marker. And you're trying to figure out, you're bugging your mom and your dad. You're like, how much longer? How much longer? Okay, like you always do, right? Like I always did when I was a kid. And so you want to figure out how much longer in order to get to McDonald's, or how many more miles till we get to McDonald's. Okay, you're probably looking at this and say, oh, I could do that in my head. Well, good. That's what you're supposed to be able to do. But I want to give you the whole idea of how we got to it. So you say you're at the 5 mile marker and you need to get to the 17 mile marker to get to McDonald's. How far do you have to go? What is the distance, right? What is the distance that you have to travel in order to get to McDonald's, right? And what did you do? You basically just went, what? 17 minus 5. I hope everybody did that. 17 minus 5, and that's 12. And so that means there's 12 miles. So the distance that you have to travel from where you are right now to McDonald's would be 12 miles. That's the distance that you traveled. So how did you find that distance? You just did a subtraction. Could you have subtracted the other way? Could you have gone 5 minus 17? Well, what would that give you if you went 5 minus 17? Well, that would give you negative 12. Do we really talk about negative miles? I don't think so. I think we just say it's this number of miles. So what we're going to do is we're always going to make sure this number comes out positive. It doesn't matter what order you subtract them. We still got a 12 here and a 12 here. This one happened to come out negative. So what we're going to do, and I don't want to get too confusing with you, but it is in the book, we're going to make this absolute value. Do you remember what absolute value does? Absolute value makes everything inside it, makes it positive. All right, so whatever you get inside of there, it makes it positive. So that guarantees that our answer, right, it was the absolute value of negative 12, which is just plain old 12. So look, we got 12 miles both ways. Doesn't matter how you subtracted it. You could have gone 5 minus 17, or you could have gone 17 minus 5, and you still get the same exact distance if you kind of forget the negative sign, and that absolute value allows you to forget the negative sign. The book does it like this. I just started off with an example right away, but the book, let me scoot this up so we can see it a little bit. There we go. The book does this. They'll make the little number line here, and they'll put a point here and a point here, and let's see, they call this x1. Say this, so we're just saying we're going along the x-axis, x1. That's our x1 point. This is our x2 point. So this is just like our 5 miles, and this number right here, this x2, represents our 17 miles. So how would I find the distance between 2 points? If I know 2 points, what would my distance be between those 2 points? Well, you could go x1 minus x2, or you could go x2 minus x1. It doesn't really matter. Now, normally, if you're starting from a smaller number going to a bigger number, to tell you the truth, this is what I would do. I would take the bigger one minus a smaller one. Then I don't have to worry about the absolute value, and I don't have to worry about the negative, that kind of thing. All right? But it really does not make any difference how you subtract this. You could go x1 minus x2, or you could go x2 minus x1, and that's what they usually do. Now, if I wanted to be real picky about this, I'm going to put this in absolute value, which does what? All that absolute value. Don't freak out over the absolute value thing. The only thing the absolute value thing does is makes sure that this thing comes out to be a positive number and not a negative number. All right, let's do an example. Okay, here's a number line that I drew out, and this is right in your book as well. And you can look at it a little neater, but let's say what they ask for. They ask you to find, they say find, and then BE. You remember from the last lesson, this means find the length of, or the measure of, line segment BE. So we want to start at B, which is right here, and we want to go to E. We want to find out how long that is. If we want to go from, this is -6. Think of this is a number line, but think of it as your like road marker or something, even though they don't have negative miles on there. But anyway, this is -6 on your number line. This is +2. We want to find the length. So how do we find the length or the distance between 2 points? Well, we subtract. Does it matter what order we subtract them? It does not matter what order we subtract them. But if you want to if you want to keep it positive, I would take the larger one minus the smaller one. -6 is smaller than 2 because it's way to the left of it. So probably the easiest way to do this would be 2 minus, now watch, what are you subtracting? You're not just subtracting a 6. What is it? It's a -6. So you do the subtraction because that's how you find the distance between two things. So it's 2 minus -6. Technically, yes, you could put that in absolute value, but we know that's going to come out positive, so I'm not even going to bother. Minus a negative is the same as plus. 2 plus 6 is 8, and there you go. Some of you are thinking, well, I could have just counted that. I could have just started here and said 1, 2, 3, 4, 5, 6, 7, 8. Yep, you could have, but we're going somewhere with this, and I want you to understand how to find the distance between two things. Let's just do one more. Let's find, let's see, FB. Let's find the length of line segment FB, or the measure of line segment FB. Well, F, let's do some different color. F is right here, and B, well, it's that same number we did earlier, so I want to find that distance. Now again, it doesn't matter what order you subtract these. You could have taken you could have, yeah, that's right, you could have taken the first one minus the second one. It wouldn't make any difference. Let's do it that way. All right, so start off with -6 minus a +5, but look what I end up with. I end up with a -11. But remember what we do? This is always an absolute value because we're always going to take the positive version of it. We don't want a negative length, we want a positive. So that just comes out to 11, and so the length of that line segment FB would be 11. Okay, now you knew how to find the distance horizontally. You'd do the same thing if it went vertically, if you just went up and down. But what if you had the length of a line segment that was kind of diagonal from here to here? Now remember, this is not a line. A line would keep on going forever, and we can't find the length of a line that keeps going to infinity, but you can if it starts and stops, a line segment. So let's call this line segment AB. So what if I wanted to find the distance, I'll put D for distance, of line segment AB. Sometimes you can see it written like that. That's how I'm going to write it anyway. What is the distance of line segment AB? Where you're like, well, wait a minute, I don't know any numbers in here. Well, you're absolutely right. So what we're going to do, if you remember that x1, x2 thing, that's what we're going to do right here. So let's call this point, you know about ordered pairs. We learned that in Algebra 1. I'm not going to go through that right here because I just kind of expect you to know that already. But let's make this an ordered pair. Now this is along the x-axis and this is along the y-axis. So this point right here, you go over this far on the x and up that far on the y. So I'm going to call that x1, y1. That's my first point, so I'll call this one x1, y1. What do you think I'm going to call this point right here? Well, I go over this far on the x and I go up this far on the y. So this will be my second point. So I'll call this x2, y2. So there's my 2 points. Now, this is diagonal. You can't just say x1 minus x2 or x2 minus x1 and then y2 minus y1. You've got to do a little bit more with this. Now, watch very carefully. What I'm going to do is I'm going to make a triangle out of it because I know how to find the distance up and down and left and right. Diagonally, I'm not sure about. So what I'm going to do is I'm going to find that distance, and let's see if that matches up. Nope, I got to go a little bit further down. Bear with me while I make that work right there. And let's stretch this down just a tad. Okay, it's not too bad. About right there. Sorry. There we go. Yeah, it's pretty close. It overlaps a little bit, but that's good enough. Tell you what, let's enlarge this just a little bit so we can see it a little bit better. All right. So what have I done here? what I'm going to try to do, remember, I'm trying to find the length of this green one, this AB. That's my goal, okay? The distance of AB. That's what my goal is. But in order to do that, I'm going to have to find the length of this vertical one and the length of this horizontal one. And I've got a triangle out of it. Now, they haven't taught this yet in this book. They actually don't teach us for a few chapters. But you probably learn this in Algebra 1. If you look at this, this makes up a right triangle, doesn't it? And so if I know one of the lengths of the sides of the legs of the right triangle, I know the other length, how could I find the hypotenuse? Again, this is a big assumption that you remember this from Algebra 1. You would use the Pythagorean Theorem. And let me just show you real quick. Now, this is not something that you absolutely have to do in your homework, okay? This is kind of like a little proof. It's like it's just a demonstration of showing you how we get to this formula that I'm going to show you in a second. All right? So just bear with me. Now watch, this point right here, I need to label that point right there. So how did we get to this point? Well, how'd you get to this point? You went over this far on the x and this far on the y. How far over on the x did we go to get to here? Well, we went x1, so this is going to be x1. How far up did we go? Well, we didn't go all the way to y1 because that's up here. How far up did we go? Well, we went up as far as this point is right there, which is y2. That might be a little confusing to you, but just take my word for it. This is over x1 and up y2, if you look at how these coordinates are made. So now what I'm going to do is this. I want to find the length of this vertical line, and I want to find the length or the distance of this horizontal line right here. So how do we do that? Let's do the horizontal first, since we've been dealing with horizontal. How do we find the distance between 2 points horizontally? Well, you would just subtract the x's. So this distance right here would be x2 minus x1. All right, I'm going to put it in parentheses. So this distance right here would be x2 minus x1. What would this distance be? Well, this is y1, this is y2, so you could do it in the same order. Now again, it doesn't matter what order you do it in because you're just going to take the positive version of it anyway. So let's just stay consistent and go y2 minus y1. And that's the length of this right here. So what do I have? I've got a right triangle, and I know one of the legs, and I know the other leg. And so how can I find this AB, or the hypotenuse? Well, I can do Pythagorean Theorem. All right. Looks a little sloppy right here. Let's clean it up a little bit, and let's put it down. We don't go quite so big here. All right, and let's try that one more time. Let's just redraw the triangle. You don't have to do this, especially if you took notes and it was a little cleaner than what mine looked. It kind of looked like this, didn't it? And you remember what the horizontal one was? It was x2 minus x1. That was the length of this leg of the right triangle. And what was this right here? That was y2 minus y1. And what are we trying to find? We're trying to find AB. So we're trying to find this. Do you remember Pythagorean Theorem? That c squared equals a squared plus b squared? That's exactly what we're going to do right here. So if I want to find this, AB, that's our distance from A to B, what am I going to do? I'm going to take, so I tell you what, you know what I'm going to do? Instead of making this a C, I'm going to make this a D. Now, why in the world would I make that a D? Because D stands for distance. So it's no big deal. I just make this a D. So watch what we have. I'm almost there with my formula. I've got D squared equals A squared. Which one is that? We'll call this one the A, and we'll call this one the B. Put it in parentheses. Remember how I did that earlier? And there's a reason for that. So I'll go x2 minus x1 squared plus, right here, and then take the other leg, which is this one, y2 minus y1. And then I'm going to square that. And this basically is my, right here is basically my formula for the distance. But I don't want d squared there, do I? Just looks kind of weird. I want distance equals something. So how do I get rid of a square root? Again, if you remember this from algebra, see, a lot of this depends on your algebra knowledge. Let's move everything down here. Let's move all this down here like this. How do I get rid of this squared? Well, I get rid of the squared by taking the square root of something. Okay, so I'm going to take the square root of this, and that will get rid of the of the squared. So I'm going to take the square root of this side. This square root will cancel with this. But I also have to take the square root of the other side. So let's write this out. I'm going to make a big D for distance instead of a little d. So the distance, here we go. This is our formula for midpoint. You're thinking, what in the world is this mess? But we can see how we got it. We got it by just doing some simple distances between the horizontal and the vertical and looking at it as a right triangle, putting it into the Pythagorean theorem, and this is what we came up with. So I'm going to put what set of parentheses. This is how I always start the distance formula. I always start off just like this. I call this the shell of my formula, okay, because I really haven't put much in here yet. I've just got my radical, my square root, I've got my parentheses and squared and a plus. So now I'm going to put the stuff in here. So what is this? This is the length of the horizontal, which was x2 minus x1. This was the length of the vertical, which is y2 minus y1. And look at that. Right there is my formula for the distance between 2 points. And that's really, really going to come in handy to you. All right, this is something I definitely want you to memorize, something that I want you to know how to work with. Now this lesson's pretty long. I've done the distance. We're going to do the midpoint later, but I think I'll split this into 2 different days and 2 different lessons. So let's do an example on how we're going to use this stuff. All right, and we'll just start right here. It says find the distance between, let's see, they put point C, and they tell you where point C is located. It's -4, -6. So this time they actually tell you the coordinates of that point. And point D, they tell you the coordinates of that as well. It's 5, -1. All right? And so this is what we're trying to find, and we're trying to use, well, we're not trying, we're going to use this distance formula in order to find the distance between these 2 points. Once we do that, we'll be finished. So let's see what we're going to do. I'll keep this up here. What I would suggest to you, every time you do one of these problems, you write down the distance formula every single time. That helps you memorize it, okay? But remember where it came from. That's the whole reason I went through all that stuff, because I want you to remember where this formula came from. If you look at it, it's just Pythagorean theorem, isn't it? See, this is a squared plus this is b squared. Where did the square root come from? Remember, this was c squared, and all I did was just get rid of that squared, and it turned that into a square root. All right, so if you kind of forget it, think about how we got to it. We got to it just by doing Pythagorean theorem. This is the length of the horizontal. This little bit is the length of the vertical. And I just stuck it into Pythagorean theorem, and bang, I'm done. It looks complicated, but when you know where it comes from, it's really not all that bad. So let's give this a shot. Here's the 2 points, -4, -6, and 5, -1. This would be, we'll call this our x1 and our y1. This would be our x2 and our y2. Remember, the first part of this ordered pair, the first coordinate is, or not coordinate, anyway, the first part of this ordered pair would be the x, and the second part would be the y. Same thing here. This would be the x, and this would be the y. So now we're trying to find the distance. It's really not that bad. Distance equals, put the shell of the formula down first. Put a big old square root, and then I always do this. Before I stick anything in there from my problem, I just set it up just like that. All right? Because I know what's going to go in here. How do I know what's going to go in here? I subtract the x's from each other. And it doesn't matter what order you subtract them in, because watch, I don't even have to worry about the absolute value on this, because I'm going to take the square. I'm going to square whatever's in here. Try it. Try squaring a number. Take 2 and square it. What do you get? You get a +4. Take a -2 and square the whole entire -2. What do you get? You get a positive number. Anytime you square anything, you'll always get a positive number. So it doesn't matter what order I subtract them in, because I'm going to square it and it's going to come out positive anyway. So let's do this. You could go -4 minus 5, or you could go 5 minus -4. I usually end up doing this, just taking the first one minus the second one. It doesn't make any difference. But I'm going to do it that way. I hope that's okay with you. So I took the x's. Notice I didn't subtract these two from each other because that's an x and a y. I took the x's, the first x and the second x, and I subtracted them from each other. So I took the -4 and the 5 and subtracted them. And then I took the y's, well, I will in a second. Then I took the y's and I subtracted them. So let's put that in there. So what is this? This was -6 minus what? -1. All right, I hope that makes a little sense. Let's continue. We're almost done. That was the hardest part. The rest is piece of cake. Watch. Just put a big old square root right here. Let's figure out what's in here. -4 minus 5 is -9. It doesn't matter that it's a negative because when I square a -9, it comes out to be a positive 81. Hopefully you understood how I got from here to here. Then you put a plus. What's this? -6 minus a negative. Minus a negative is the same as plus. -6 plus 1 is -5. But if I square a -5, I get a positive 25. Notice that I will never get a negative inside. Well, yeah, I guess for this I can say that. I'll never get a negative inside of this square root right here. All right, because I've squared both of these, it'll always come out positive. This is always going to be plus, and so I'm good to go. And so what do we get here? That's 106, I believe. So it's the square root of 106. And I'm fine if you just leave your answer just like that. I'm perfectly okay with that. You don't have to put it into a calculator and get some decimal number. Just leave it like that. If it really bugs you, then feel free and go ahead. So let's see. It'd be square root of 106. And that would be about 10.3 if we round it. I'll put approximately 10.3. But to tell you the truth, I would just keep it the square root of 106. Okay, no reason to try to put it into a calculator. You could always make a mistake that way. I would just keep it just like that. So what did we actually find? What in the world did we find? We found the distance between these 2 points. Let's just do a quick little sketch and then we'll be finished. Okay, you don't have to do this, but I just want to kind of give you an idea of what you just found, because sometimes people know how to put it in equations, but they're not really sure why they're doing it or what they're doing. So what is this? -4, -6, 1, 2, 3, 4, and then -6, 1, 2, 3, 4, 5, 6. So the first point, point C, was right here. And then point D was 5, -1. 1, 2, 3, 4, 5. And then down 1, that would be point D. So what did we just find? We found the distance between C and D. See the length of that colored line right there? That's what we found. It's about 10.3, or the square root of 106. We found the distance, how long that line is, and it's a diagonal line, so that's when you would use the distance formula. Well, I hope that made sense. I tell you, if you go to, I don't know if I've talked about it in class yet or not, but if you go to Khan Academy, let me just write that down. He has good explanations on there. So if you go to www, and then Khan, Khan, I don't know if at this point I've discussed that in class or not, but it's always, and it's .org. This is a great resource, great resource, okay? KhanAcademy.org. He's got videos very much like, this is how I've modeled my videos after him. His name is Salman Khan, and go to that, and he's got tons of stuff. If you go to KhanAcademy.org, just do a search for geometry. He's got like 104 lessons or something like that just on geometry. You do a little search for distance formula. Okay, so just do a little search for the distance formula, and he'll give an explanation. And to tell you the truth, it'll look very close to my explanation, but sometimes hearing somebody else can be very helpful. All right, so this is only the first half of section 1.3, and I'm already at 24 minutes. So I'm going to do the second half, the midpoint formula, in another video. It's a lot to cram in one class period. So next day we have class. I'll just assign problems from the distance formula, not the midpoint formula. I'll wait one more day until I teach that on the video. All right, well, see you in class.